Hey, hello everybody. We're going to start a new chapter today, but I was thinking before I started this, I wonder what the number of the day is. I honestly haven't thought about it too much, but I know we left off somewhere. I think we were in the high 50s or something like that, so we must definitely be somewhere in the 40s by now. Although I suppose if we don't count the Wednesdays, I'm gonna have to figure that out. If someone knows what the number of the day is, get back to me. Let me know. Otherwise, I'll have to figure that out, and I'll maybe have to bring that back to these virtual lessons. But in the meantime, today we're going to take a look at three-dimensional figures. We just got done with the chapter doing areas, perimeters, but everything was flat. Everything was laid out in 2 dimensions. And so now we're going to add a dimension to that. We're going to move into the third dimension. Maybe some of you have gone to a 3D movie, or you've seen 3D glasses that you wear to make things look like they're coming out of the screen. Well, this is where we have to use our imaginations a little bit. So even though I've got diagrams on my video right now that are literally 2 dimensional, we have to imagine that they're 3 dimensional. We have to imagine that this box is coming out of the screen at us, and it has depth and width and height. Um, and so we've got just some typical geometric figures here, and then I've got a tent and a house that are 3 dimensions. We're going to see lots of different types of 3 dimensional figures. This is an image from an album that, well, if your parents are watching this with you, or maybe if your grandparents are watching this with you, maybe they recognize this symbol from an old album by Pink Floyd. But a prism is an actual geometric figure. We're going to be talking a lot more about it in a couple days. But this prism, or all prisms, are named for the shapes of their bases. So you've got two bases here. One of them is this pentagon that's in the front, and then I've got this other pentagon that's in the back, and they're all connected by these either parallelograms or rectangles, depending on what type of a prism it is. And we'll focus more on that when we get to actual prisms. Um, but here's another shape that is technically a prism. But if I didn't tell you about prisms, you might just call this a box, like a shoebox or something like that. But the actual technical name for a shape that looks like this is a rectangular prism. Or I suppose if these are squares on the sides, you could call it a square prism as well, but definitely a rectangular prism because, of course, a square is just a type of a rectangle. Another three-dimensional shape that we're going to be taking a look at is something called a pyramid. A pyramid is a lot like a prism, except instead of having two bases, it's got one base. In this case, the base is a six-sided figure. Hopefully you remember what that's called. Since it's a hexagon, this would be a hexagonal or a hexagonal pyramid. So you could have a triangle as the base. This would be a triangular pyramid, a square pyramid over here, like the ones that are in Egypt, a pentagonal prism, and this looks a lot, excuse me, this is a pyramid, pentagonal pyramid. This looks like a pyramid, except instead of a polygon on the bottom, I've got a circular base. And so the word cone we'll use when we're describing something that looks kind of like a pyramid, except the base is a circle. And here's another image that if your parents are watching this with you, they might remember the movie Coneheads that came out a long time ago, or maybe if your grandparents are watching this with you, they remember the old Saturday Night Live skit with Dan Aykroyd and Jane Curtin with cones. And so different sizes, different shapes of cones, but what they all have in common is that they have a circular base and then doesn't really have polygon sides, but they all come up to a point. So some of the different three-dimensional shapes that we're going to be taking a look at in this chapter, but really what we're going to focus on today is something called nets. A net of a three-dimensional figure is a two-dimensional representation that could be folded into that three-dimensional figure. So over here on the right, I've got this shape. It's actually got a name. It's called an icosahedron. Don't worry, you don't need to know that, but that's what this shape is called. This is actually a shape that's inside of a magic 8 ball. If you've ever seen a magic 8 ball, there's actually an icosahedron. There are 20 different responses that are written on different sides of these triangles. And so when you shake up the 8-ball, one of these shows up on top and you can see what one of them says. And then there's a dark liquid around it that you can't see through, so you can't see the other sides. But anyway, if you took this shape, and imagine if you took a little X-Acto knife and you cut along each one of these edges and laid it out flat, it would look like this. Or maybe you've seen books and things like that that have these patterns that you can cut out and fold up into a three-dimensional figure. That's what a net is. So this is a three-dimensional figure that could be flattened out into this thing called a net, or this net could be folded up into this three-dimensional figure. What's going to be useful for us is that when we're trying to figure out what surface areas are coming up in a couple days, well, to find the surface area of this, we're going to be splitting it up and laying it out flat. So, well, look at this. If you look at each one of these shapes, it's a little equilateral triangle. And so if you found the area of one of these triangles, the surface area, the total surface area of this icosahedron is just the sum of all of these little areas. So we could figure out how many there are. Spoiler alert, there's 20 of them. And if you found the area of one of these triangles and multiplied that by 20, we're finding the total surface area. But again, that's a topic for another day. Here is a net for a different shape. I'll give you just a moment to think about what three-dimensional shape you would make if you took this net and folded it up. And if you're like me, you're imagining a cereal box right now, because when I'm done with the cereal box, I flatten it out so I can take it out to recycling. And this is what it looks like after I've flattened it out. You could think of the front of the cereal box over here. Here's one side of the cereal box where you've got all the nutritional information. Here's the back of the cereal box. I've got the other side of the box over here on this side. And then on the top, well, there's the top of the box, and down there's the bottom. And so if I tried to draw what this looks like, here's the front of the cereal box. And I've got the top over here. My dotted lines down here because I don't actually see this through the rest of it. Oops, I'm gonna get rid of that one. So maybe there's the right side, and then here again on the other side that I can't see. If I could see through the box, I see that. And so if this is the front of the box, that would be right here. If this is the right side, that ends up over here, etc. And so that's the idea, to take a net and fold it up into this shape. Here is another net. Again, I'll give you just a moment to think about if you folded this up and made a three-dimensional figure out of this, what would that figure look like? And here comes the reveal. This would make a shape called a cylinder. You've probably heard the word cylinder before. A cylinder is like a can of soda. We've got the top of the can over here, the bottom of the can, and this is almost like a piece of paper. If you could take a piece of paper and fold it around into a circle, then you got the top and the bottom, you would make a shape that looks like this. And so when we're talking about surface areas and volumes, we'll be using those formulas that we had for circles. The area of a circle, the circumference of a circle, those are all going to come into play when we are looking at a shape like this. Here's another fun example of a net that could be folded into a three-dimensional figure. Think about folding this one up, taking all those little pieces and folding them up around each other. You're probably imagining what this looks like. I know that many of you have seen this shape before. This is actually the net of a soccer ball. Imagine if you took a soccer ball and all along those seams, if you took that thing apart. Now these two images down here, this one is actually what it looks like when it's flattened out. If you then inflate it with air with lots of pressure, it gets more rounded because of just the spherical shape of the bladder that's inside of a soccer ball like this. Now let's go in the other direction. If I have a three-dimensional figure like this pyramid, and I laid it out flat, if I, again, took an X-Acto knife and cut along some of these edges, and flatten this thing out. Imagine what that would look like. This is actually what your homework assignment is going to look like tonight, taking a three-dimensional figure and imagining what it looks like when it's flattened out. Well, if this shape down here, if this is a square pyramid, if the base is a square, I'm going to put that square down here in the middle. And then I'll think of each of these faces, each of these triangles flattening out, laying out flat on each side of it. And so maybe that shape would be this shape over here on this side. I'll color code this. We'll take this triangle and lay that one out flat. That's going to look like this up on the top. I'll make this one over here blue. This face gets flattened out over to the right side. And I'm running out of colors. I haven't used red yet. This shape will kind of flatten out to the board in our direction. It looks something like that. You certainly don't have to color code if you don't want to, but I thought it might be helpful to see them all laid out flat. So this is the three-dimensional figure. I'm actually going to erase all of that stuff in the way. And then this is the net for that square pyramid. Here is a hexagonal prism or a hexagonal prism. I don't know if there's a technically correct way to pronounce that. The bases are hexagons, and we've got these, looks like squares connecting those two. I want you to think about what a net of this would look like if you cut it and laid it out flat. And I actually want to show you two versions of this one. I've got these ready to go. One way to do this is to think about cutting along each of these vertical segments and having them sprayed out, kind of like we did for that pyramid, how I kept the base where it was and I flattened everything else out around it. If I take the base of this one and lay it out flat, and take all of those side rectangles and lay them out from that, and then on top of one of them, I attach the hexagon. I didn't have to put it on this one. I could have taken this hexagon and put it over here, or put it down there. Any one of those is okay. And this is one way that we could lay out a net for this hexagonal prism, or a way that I think is going to be more useful for us is to lay it out in a way that looks like this. So here, I'm almost treating it like a can of soup where I'm cutting along all of the edges up on the top and cutting along the edges on the bottom. And then like with the cylinder where these side edges, I'll lay them all out flat edge to edge. And I've got the top up here, I've got the bottom down there, and that's another way of laying it out. The reason this one's useful is instead of looking at this as 1, 2, 3, 4, 5, 6, 7, 8 different shapes that I would have to find the area if I'm trying to find a surface area, for this one, I can think of this as just 3 shapes. I've got the 2 hexagons, and then I've got this great big rectangle. And what we're going to see tomorrow when we look at something called lateral area is that if I think of a label on a soup can as these sides all around here, well, that's just one big rectangle. And rectangles are easy. Base times height, where the base of this is just the perimeter of the hexagon, and the height of that, that's just the height of the prism. So for your assignment tonight, it's on Schoology in the regular place where assignments are. Go ahead and do this one on Kami. You're going to see that the next 3 assignments are all going to look very similar. Tonight, all you're going to do is lay things out and draw what the net looks like. So I'll show you an example right here, an example how to draw a net of this shape. By the way, this shape, I've got a triangular base. So this is a triangular prism. And there's a few different ways that I could do this, but the way that I'm going to lay this one out is I am going to have this side right here, this 7 by 10 rectangle. I'll just kind of lay that out in the middle. As I said in the directions, I want to label the side length. So I'm going to say that this side is 7 units tall. This length of 10, that's going to go right down here. And then if I flatten this thing out, this side here is 6, this one is 7, this rectangle is a 6 by 7 rectangle, so I'm swinging that one around over on this side. So that 6 length ends up over here. And it'd be the same down here. I don't need to label both of these sides, just like I didn't label both of these 7s or both of these 10s. You can certainly do that if you would like to, but if I've got opposite sides, I don't need to label both of those. This back side over here, I'm going to swing this around. It's got a height of 7 and a width of 8, so I'll bring that over here and lay that one out flat. So I've got the side length of 8 over here. And then this base that's up on the top, this triangle, I'm going to fold that one up to look something like this. Now that side of 6 looks like that. That side of 8 goes right there. And then the same thing on the bottom. This triangle that's on the bottom, I'll swing that one down to be something like that, where this side is 6 and that side is 8. That's what your homework assignment is going to look like tonight, just laying them out, labeling sides. Tomorrow, we're going to talk about finding the areas of the lateral faces. I'll need to tell you what that means tomorrow. We'll be actually doing some calculations based on this. So tonight's all about drawing the nets. Tomorrow, we'll move on from there and do some calculations. Good luck with the assignment tonight. As always, certainly get in touch with me. Let me know if you have any questions. Otherwise, I will see you virtually tomorrow. Peace out.